maybe not a regular PHP conference speaker. And I try to do that every year, try to invite someone from a entirely different community and background, because it gives us kind of a fresh perspective on code, and we get to hear from someone you may not usually see at a PHP conference. But the next speaker is Sandi Metz, who I'm sure many of you have actually heard of, well known for her book, which is known by Pooter, or Practical Object-Oriented Design in Ruby. And she's going to talk to us about coding today. So here's Sandi Metz.
So I'm just going to hit this button to make my timer start, and then I'm going to use some precious minutes talking to you. So there was it my imagination, or was there alcohol out there during the last break? Did you guys get a drink? Or were they were just setting up? Good, because I'm not allowed to drink till I'm done. And it would break my heart if you all had a drink. It's true, okay, I don't get out much, and I've never been to a PHP conference. I flew in this morning from Raleigh-Durham. And yeah, and I'll be at the games night tonight. I had just time to check into the hotel and take a quick shower, and have a couple of conversations with people at this conference. And you know, you guys I can't really see you. You seem quite nice. I'm really happy to be here. So thanks to Taylor for inviting me, and thanks to you. Okay, so this guy, Kent Beck. Yeah. So he wrote, you know his name. He made the term code smells popular when he worked with this guy, Martin Fowler, on this book, Refactoring, back in the 90s. They collaborated on the 3rd chapter. The two of them wrote it. And so, tell me, I can't really see you, and I'm going to try. So everybody knows what a code smell is, right? So I teach a class in object-oriented design, and every time I ask that question to the people in my class, they all say, oh yeah, we know, code smells. And then I say, name 5. And no one can. Yeah, no one can, right? And so here's the thing. We have this notion that, like, the term is popular, it's entered the common lexicon, but we think of it as meaning, I don't like the code you wrote, and I can't explain why, right? That is not what a code smell is. And so I'm basically going to do a book report today. And then I'm going to show you, I'm sorry, some Ruby code, because that's where I live mostly. In the Ruby community, you'll be fine. It's easy. You'll be fine. So I'm going to call them classic smells. These are the smells that came right out of chapter 3 of that book. I have a problem with this list because it just seems like a long list of things. And fortunately, well, first let me say this. The reason code smells won is because they gave names to things. And you just heard Matt talking about that, right? Naming things is almost all that we do. And coming up with good names for things is incredibly powerful. And so these guys sat down and they looked at all kinds of different coding problems, and they gave names to certain patterns that they saw. Now, I'm a woman of a certain age, and I went through I went to a desk every day for 35 years and wrote code. I didn't know the names of these code smells because I couldn't read the academic literature. And I found the Refactoring book hard to read because it's a series of recipes. Someone once likened it, and I needed a story arc. I needed a plot, and there wasn't a plot, right? It was just list. Someone once described it as reading a cooking book for someone who didn't eat. Right? So I found many of these, I did not know what these things meant, and I couldn't have described them. And then when I wrote a book eventually, and then somehow people thought that I had read everything. Like I wrote a book, so people assumed I'd read all the books, and so I frantically went on this sort of world book reading tour. And I struggled my way through this, but even then I had a hard time following it. And then I stumbled across a paper by a guy who grouped them into categories, and that really helped me. Before I get there, when people talk about code smells, very often they prefix code smell with the word bad, right? They don't just say code smell, they say bad code smell. And they say it as if you have to protect yourself from the smells, but it's you don't have to go out and buy a gas mask. You don't have to remove all the smells from your code. you just have to be familiar with them so that you know how to behave. Now, it is true that there's a practical reason to understand code smells, but it's also true that they do have wonderful names. Shotgun surgery. Primitive obsession. When I teach the class, I often have people do art, and we've had some very interesting visual depictions. Often there's some person with like a bone in their nose. Anyway, so there's a guy named, I can't pronounce his name, sorry, it's Mantilla, and he took this list of classic code smells and he grouped them into 5 categories. And now, through the power of Keynote, I'm gonna get rid of those 2, and I'm gonna do that. All right, and already that helps me because I'm only looking at 5 things. And so I'm gonna spend maybe 10 minutes here and just run you through all these smells and give you a little taste of what's behind them, what's involved. And so we'll go through them category by category. The first category is this one. It's things that just don't need to be that big. And so you probably know, like, it's pretty clear what long method, large class are. Data clump, I'm going to show you a code example of later long parameter list. Probably there's an object in there somewhere. Primitive obsession, in case you're unfamiliar with that, primitive obsession is that thing where there's a base type in the language that you're using, string or hash or array or something, and you new one up, you create one, and you pass it around, and everybody that gets it looks at it and does something. They say, if the value of this number is 3, I'm going to do something. Or if this hash has key X, I'm going to do something. So you take a data type, and you pass it around as the object, and you make all the receivers of that apply behavior. That you end up with a lot of that code. Everybody who takes that object as an argument has to supply that behavior. So that's bloaters. The next category, we'll do this one. Switch statements, these are things that are, features that in your language, that are built into the language that you could misuse. I'm a big bicyclist. I'm an amateur bike mechanic, which means that in my garage I have all the worst tools, which means that I have had occasion to put a piece of pipe on the end of a wrench and try to break loose a set of pedals or a bottom bracket. And I can tell you that it's a dangerous operation. You can absolutely hurt yourself. So this set of things is called tool abusers. Switch statements, that just means conditionals. You can misuse conditionals. Refused bequest is when you have some kind of inheritance hierarchy, and you subclass a superclass. You create a subclass, which ought to be a specialization of the superclass, and in that subclass, you override one of the methods you inherit, and you say, I don't do that. You refuse the bequest. Alternative classes with different interfaces, okay, don't do that to me, right? You told me I can have this or that, and then they conform to different APIs. Or temporary field. It's interesting that a temporary field is considered a code smell. I'll use some temp fields later. We'll introduce that code smell in this talk. So this category is things that are perhaps abuses of the tool. Next, we have this group. These are things which prevent change. And it's interesting now, for the first time in this talk, we're in the category of thinking about what happens to code when we change it. Divergent change means that things that ought to be the same end up being altered, changing in different directions over time. Shotgun surgery, which truly is one of my favorites. Shotgun surgery is when you're asked to change the code that represents a single concept, and you have to go edit code in a bunch of different places. It means you either have duplication of code or duplication of that concept spread out in more than one place. Parallel inheritance hierarchies is just what it says. So these are things where if you have these things in your code, if your code is arranged in this way, it's the kind of thing that makes you not want to edit it because the cost of making change is high. All right, change preventers. Next we have these things. So these are dispensables. Lazy class. A lazy class is a class that doesn't have enough in it to justify its existence. It just adds a level of indirection and creates complication, which adds confusion for no purpose. Speculative generality, I'll come back to. That's our biggest sin. Data class, if you're doing OO, right? If you're doing PHP OO, then what you want is objects that have data and behavior. Doesn't make much sense to create objects that just do data, and then duplicated code, which is obvious. So these are things that you ought to be able to get rid of in your code. They are to be dispensed with. And then finally, this last category, feature envy. Feature envy is when an object knows more about, when you send more messages, when object A sends more messages to object B than to itself, it envies the features that other object has. Inappropriate intimacy is just a worse form of that. And inappropriate intimacy is like feature envy, except you're using private methods on that other class. So you break into it and do the private parts. Message change, sorry. You know, every time I talk about this, I say something that's a violation of the code of conduct. I do not mean to. Message change, we're going to refactor a message change in a little bit. You may know them under their other name. People would call it the law of Demeter, however you want to pronounce that. And then middleman. Middleman, again, is a class that doesn't justify its existence. You could have an object that does nothing other than take messages. I could have B, which gets sent messages by A and forwards them onto C and does nothing else. Right? That's again, a place where we added a level of indirection that serves no purpose. So these are couplers. They stick things together. They bind apparently unrelated objects together such that you can never reuse one of them independently. It's a whole woven carpet, and you can't reach in and grab a single thread. You have to get the whole thing with you. This has reuse consequences, and it also has serious consequences in your tests. All right, so there they are. That's the whole pile. That's it. You think, okay, so I've been talking 11 minutes on the nose, and we're not done. Now you could and should go read those code smells and learn more about them, but really I'm here today because of a thing that it seems like we used to know and then we forgot. And here's the thing, this word, refactoring. Okay, refactoring has an official, very precise definition, and it doesn't mean just to go move code around. All right? In the book, in Martin Fowler's book that I referenced in the beginning, he defines it as altering the arrangement of code without changing its behavior. Let me say that again, altering the arrangement of code without changing its behavior. And what this means is, what it doesn't mean, actually, let me go there first. What it doesn't mean is, you know, very often we get a new feature request in and you say, oh, I'm going to have to refactor the code to add this new behavior, right? It's common that we mix those things. We rearrange code and add new behavior instead of rearranging code without adding new behavior. The nice thing about separating the adding of a new feature with the rearrangement of code is that if you have tests, and I would urge you to write tests, those of you who aren't yet doing it. I didn't used to write tests either, and when I started writing tests, I sucked at it. It really slowed me down. I thought I was a good programmer until I started writing tests. But I got better, and you will too. Right? I'm afraid to write code now without tests, and I'm much more productive now that I buckled down and learned it. So I would really, it would improve your code if you have tests. So I'm assuming from here on that you have tests. So if you have good test coverage and you refactor, it means if your tests are running green, you have a wall at your back that proves you never broke the code as you rearrange it. This is a wonderful thing. Imagine being able to make any change you want in your code and know that you did not break something. If you have good tests and you're only doing refactoring, then you can do that. Now, the nice thing about if you're doing real refactoring comes as a series of recipes. Like I already said, Martin Fowler's book is it's a list of shrub, just like that. A million things. There's no big story arc after you get past the chapter on code smells. But here's even the better news. This piece of news is kind of a secret. Every refactoring recipe, here's one, extract class. This is page 149 of Martin Fowler's book. You notice that it has, you know, steps, and then optional things, and then these things that have capital letters are references to other recipes. So this is extract class. Every code smell can be mapped to the recipe that cures it. Here's an example. This is data clump up here. This is from a cheat sheet made by the guys at Industrial Logic. This refers to Fowler's book, page 81. This is a short little definition of about what data clump is, and this is a list of all the different refactorings that cure it. This cheat sheet is huge. It's got all the code smells in it and a bunch of different references. Here, F stands for Martin Fowler's book. This K is Joshua Karievsky's book, Refactoring to Patterns. So here's what this means. The problem is solved. You're making it too hard, right? You're making it too hard. It's really pretty easy. If you only knew, if you could identify and recognize code smells, then you could look up the curative refactorings and apply the recipes to fix the code. Now, we've been in this situation where, because we don't know code smells, we look at code that's messed up, and often there's not just one smell wrong, there's many smells wrong, right? There's a lot of different things wrong in any piece of code. And, well, tell me this, let me ask you this question. Who in here has ever undertaken to refactor, by whatever definition you want to use, undertaken to refactor some code and made change after change after change and gone a day or 2 days or 3 days and finally just thrown it all away and started over? Who's done that? Raise your hand. Yeah, we've all done it, right? And what is it? What is it about, what quality does code have when you get in that situation? It's because every time you try to fix a thing, you can't get it finished before you have to fix something else, and then you don't quite get that finished and you have to fix something else, right? And you chase that beach ball on the outgoing tide until you catch it or drown. That's what happens, right? You get way far away from shore, and then you just have to give up and throw all your code away. It's a real challenge for us as programmers to reach into a mess of code and surgically extract a single piece and improve just that piece and get it done without breaking other things. And knowing code smells, if you learn code smells and you fix them one at a time, it gives you affordances into changing code in that way. All right, so now I'm gonna get you to look at some code. I'm not even gonna apologize for the fact that it's Ruby code. You'll be fine. I looked at PHP all day. I didn't have any trouble following it, right? This okay. So here, if there's any part that you don't get, just yell. So this is a class. This is a class declaration. It's subclassing. It's inheriting from something called persistent. This is class foo. Foo has a method, sales total. It takes an argument. It's called params. It knows the name of another class. It knows the name of that sale class. It sends 2 messages. It sends where directly to sale, and then it sends some to whatever comes back from where. It knows the name. These are 2 different, they look different, but they're actually the same thing. This is a symbol in Ruby, and that's a string. These are both attributes on class sale. So sale has date, and sale knows date, and sale knows sum. This bit in here, these are, in that params hash that got passed in, there's a starting key and an ending key. Those are string variants of dates that users typed in. And so we're calling date parse in order to turn them into actual dates. The dot dot here in the middle creates a range. So there's a range object in Ruby, and this is a date range. It has a starting date and an ending date. So this syntax here, let me just glance at the next slide. Okay, so here, the where method on sale, which it inherits from persistence, has an attribute date, and it's the database API is capable of finding a date within a range. That's what that means. All right. And then maybe you have a bar class, and it has, I don't know, weekly sales total. It takes the same kind of params hash. It only needs, in order to get weekly sales, all you need is a starting date. Like, you can figure out what the ending date is if you know they want weekly sales. And so here it just takes the starting date out of the hash, it calculates the ending date, and then this looks a lot like that thing we just saw. It's interesting that sameness can be hidden in difference. And it's a thing we do all the time in our code. We try to be concise and write shortcut code, and as such, we often we disguise sameness as difference when they're not really different. And that's a case of what happened here. These things are a lot more alike than they look on these slides. And then, of course, if you have sales, you probably also have expenses. So we got BAS, and there's an expense total. It takes params. It knows the name of the class. It's a very similar thing that we've had, except in this case, of course. And so imagine these have been written gradually over time. And in this case, some user typed some weird thing in and it blew up. And so whatever programmer got that ticket went right here and put some validation. And so they decided, maybe arbitrarily, that today's date was the right date. If that's not a valid date string, I'm going to use date today. And if that's not a valid date string, I'm just going to say, well, you meant it to end on the day that it started. And so now, this is not much code. But I'm just going to highlight the number of different ideas in this small set of code. So there's that. There's the idea that I know what a week is. There's the idea that dates might need validation and that there might be reasonable defaults for that. There's this notion, there's these two things that always seem to come together, this pair of starting and ending date. There's this message chain where I know somebody that knows where, and I know that whatever that message call returns knows some. And then I also know that the objects that I'm talking to have a date attribute and a cost attribute. And so what? Is this bad code? Should we care? And the truth is, if it never changes, I don't care. Just check it in and walk away. Right? Seriously. Like, making this more complicated, my criteria, the question I always ask people when we talk about whether or not we should improve code is I want to know, how will it save me money? And I cannot imagine this code as it exists really ever cost me money. But let's imagine that this app is more like the apps that we often work on, and that because I have a foo and a bar and a Baz, that I eventually get a Larry and a Curly and a Mo, and they do all these same things, this stuff, and then a fee and a fi and a fo, right? It propagates, it spreads out all over. And eventually what happens is, this is what your app feels like. It's full of duplication. It's got tons of message chains. There's data clumps repeated over and over again in there. You have to do enormous amounts of shotgun surgery if you change anything. And it's likely, while you're doing shotgun surgery, that you'll miss one or two of them, and something will break in production. And so when you get to this point, the accumulation of simple problems creates an overwhelming, incomprehensible mess. And if you attack all these problems at once, that's when you're chasing the beach ball in the outgoing tide. Right? This problem is very hard to fix. The accumulation of simple problems has really turned into a big problem that's hard to deal with all at once. And so the way you reach into this mess very simply and grab one thread and extract it and fix it is to use code smells. And so let's just do that. First one, we're going to remove all those three colors by identifying the data clump and applying the curative refactoring recipe, which is extract class. I'm not going to oh, I guess I am. Oh yeah, so sorry. See, this is what happens when I stray from my speaker notes so I can get closer to you. Yes, we're going to do that. So this is the data clump. These are two, so now I'm going to define data clump, right? Data clump is two or more bits of data that always seem to appear together. Now, the interesting thing about data clumps is they seem so innocuous. But here, if you look at this data clump, what you'll notice is that there's behavior that's being supplied for it. There's this concept of a date range. And I might want to know that starting and ending date, that concept of a week somehow has something to do with the dateness of it. And the concept that they might be invalid is also about the dates. And the concept that I know what the default could be is also about the dates. And if I let myself put this data clump everywhere, the data clump is bad, but it's not the worst part of this problem. The problem is the behavior that ought to be related to that, the object I don't have, gets duplicated all over. And it's entirely possible that someone will do what I did when I first wrote this example and say start date plus 7 someplace and not have a test that catches it. And it's also entirely possible that someone will do something different here. Some people don't have validation, some people do. The validation can be different. Like, this behavior could be different or missing in every place it needs it. And so I'm not going to show you the refactoring. That you can follow, you look it up in the book, extract class. You can follow it. If you'd done the refactoring, you would get a class like my new date range class that takes 2 arguments, starting and ending date. It defaults ending date to nil. The validation is right here in the initialize, because I'm not going to hold on to bad data. I just will not. We'll fix it right at the front. And then it has 2 methods, a range method and a weak range method. And so this object now can stand in for that data clump, every place I have it. And so let's just go use it. So here's the foo class, the original one we saw. Now I'm going to make this code. This is a paradoxical thing about OO. It can seem as if you're making things worse before they get better. And it's often true a little bit in code. It gets worse as you try to do more OO things before you start reaping the benefits. And it's going to look like that here. I have one line of code. It looks just like this. I'm going to declare a temporary variable. That's a data smell. So I can get a new date range and store in it. And then I'll use range right here. I'll use it in that spot. So that's foo. If I ran a static analysis tool on my code, it would report that it got worse. So there's more lines of code. I declared a temporary variable, right? Blah. But let's do more of this. So here's bar. Bar is the one that does weekly sales. I don't need that. I can just get a date range and ask it for its week range, and then send it. All right, so that got better. Baz, I don't need that. I just get a range. They're valid, and call it. And so now I have these 3 new classes, and all of the data, the object that holds the data clump is being used in every single case. And so what this means is that the way weeks get calculated, the way errors get handled, and the defaults that are put in are the same no matter who uses it. And when new people come in this app and write code, they are not going to handroll this. They're going to use new instances of this new date range object. What you'll find, okay, so here, let's do that. So if you remember nothing else from this talk, go home and get rid of your data clumps. It gives you a place to, what you'll notice is that if you make those objects, behavior will coalesce into them. It may feel like to you that they don't do much, but those 2 or 3 bits of data that travel around together all the time very often make the people who are operating against that data supply the behavior. And if you can put that behavior, you can create an object and put the behavior in it so that you can send a message to the object instead of supplying the behavior yourself in a procedure. What you'll find is you can test it, and you get easy consistency across all of those objects. So data clumps, if that's the only code smell you know, and you can remove them from your code, it's worth the price of admission. All right, but that's not all. Message chain. So here's a message chain. Right? I'm sending a message to an object, not to myself. I send it to sale, and then I send another thing to what sale returns. It can be really hard to understand why message chains are bad, and I'm going to attempt to explain it to you in 2 different ways. This first way, I'm just going to show you the messages that get passed. So that's my class foo. We have that sale class, and foo sends where to sale. So far, so good. Sale inherits from persistence. It's made the devil's bargain that it will accept the dependency on persistence, the dependencies that inheritance gives you, so that it can know the where message. And then way back behind persistence, somehow, there's a whole bunch of other stuff, none of which I should know anything about. And so when foo sends where, then where chases up to persistence, and persistence does something to get some kind of list object, and it comes back, and that comes back, and that goes back, and then foo jumps across that boundary and sends some to the object. Now, what's going on here is that I am dependent on something that persistence might feel perfectly that it might feel as if it was perfectly legitimate for it to change. I do not want, like if you're doing this with your framework, and using all the bits of however SQL works and bringing them out into your objects, knowing a message this guy knows and a message things behind it knows, what you're doing is you're binding yourself to the internal implementation of code you don't own. And not that I'm suggesting that your framework is ever going to go away, but I live in the Ruby on Rails world, and I give them the same caution. Right? You don't know what's next, and you want your own application's code insofar as you can to have dependencies on your own code. And so we'll come and break that dependency in a minute, but this is part of why this is a problem. Now I'm going to do this, I'm going to draw this exact same idea. I'm going to illustrate this same idea a different way. So here's foo. Foo has a ring of collaborators. It knows about the date range class, and it knows about the sale class. And they're immediate. These are the objects it knows about. These are the objects that you have to set up in the test that Matt was talking about. You have to know these. However, when foo knows to send some to where, what you're doing is you're going out into the ring that involves knowing about your collaborators' collaborators. And when you find tests set up hard, for those of you who are doing testing, or maybe those of you who have been driven off from testing because you have this problem, when you find that your test setup is really expensive, basically you have to new up your whole database, right? You have to create every object in your app and get them all wired together before any test will run. It's because you're committing Demeter violations. You have objects that know about objects that are outside the ring of immediate collaborators. This is never going to work out for you. Going back again to the idea of testing, like tests, I know there's some, okay, here, I'll just say this straight out. I think of testing, my tests are just code in my app. And they are code in my app that wants to use other classes that I wrote. And if I find that my tests have a hard time using my own code, it means I can't write any other code that uses that code. The amount of setup that you have to do in a test to get it to be able to operate on an object is exactly the amount of effort you would have to use any place else in your code where you wanted to reuse that object. And so the tests are a canary in a coal mine in terms of your object-oriented design. If you find that testing is hard, it probably means that your design is bad. Now, I say that because I say that as someone who wrote Smalltalk for many years. I had piles of OO code before TDD became a thing. And we thought we were really good and smart programmers. And then testing showed up. And so we tried to retrofit tests over our code, and it was impossible. And it was because the design was so bad. Well, there it is. So if you find that you're trying to learn testing, I would not recommend first attempting to learn it by retrofitting tests around existing code. You might find that it is almost impossible to put test harness around that code because you didn't realize how bad your code was. And so one good reason to start writing tests is it'll force you to write better code. It'll force you to write more decoupled code. All right. I'm going to talk a little bit more about the consequences here on how this makes your test slow in a second, but first let's fix this message chain. So here it is. Now the reason I have a message chain here, this is always true when you're doing this ... thing. There's something there that you didn't give a name. And names are hard, and so we often punt. Like, don't be lazy. Name it. And so here, what we know is that I have a series of methods that have a repeating suffix. And when that happens, it's trying to tell you what the name of the message should be. What should happen here is there ought to be a total method on sale. And in this case, now that if I put a total method on sale, then sale can send where to self, and there's only one dot in that chain. It's allowed to know that the thing that comes back knows some. And if I do that, if I create that method, then I can change these like that. And so now notice that the sale class, it's a class of my own and inherits from persistence, but now it doesn't know the message it's sending to self are not part of the API in the framework. They're my own messages. They're concepts in my own domain, this total. And it's the same thing can be true for expense. I can just do that. All right. And so that gets rid of the message chain. There's the new method, and then this is message chain hide delegate. Now I'm going to do one slight digression. Okay, plenty of time. Reality. Again, Matt just talked about reality. It's an interesting question about testing, about mocking and stubbing. So I told you before that I wrote code for literally, I'm a woman of a certain age. I wrote code every day for 35 years. And then I wrote a book, and it was like a bomb went off in my life. So I had to quit my job. And so I did, with no visible means of support. And then I eventually started teaching a class in object-oriented design. And so people called me up on the because of that book, people would call me up and they would say, come to our shop and look at our code and tell us how to fix it. And okay, this is a horrifying thought, right? Like, okay, you have a really big dev team, and you've been working on this app for 10 years, and you have a mess that even you don't understand, and you think you can pay me enormous sums of money to walk in your door and look at some code and figure it out. It just seemed as if, it just terrified me, frankly, right? And so I found, however, that when I went to look at people's code, that we're all making the same mistakes over and over again, and we're too close to them. We're so close to them that they blind us. There's two big problems that people have. One is conditionals, which we're not going to talk about today, but the other is slow-running tests. Their tests run too slow. So they don't have tests, or they quit run. Their test weeks either run 3 or 4 or 5 or 8 hours, or they quit running them altogether, and their code is then unreliable. And the problem I see is this. This is the problem I mostly see. So notice here we got sales. Sales is a subclass of persistence. It made the devil's bargain. It's dependent on the framework. My own class is foo. In this case, it's a plain old Ruby object. It does not inherit from the framework. It's business logic for my app. The question is, how are you going to test it? Now, I know I'm forcing some new syntax on you again. This is mini test. It's just yet another test framework. I'll just go through this. The given when then is all jammed right into this one line. It gets a new instance of foo. It calls this method sale total, passes these 2 strings to it, and it asserts that the result is 28. Now, what this means is, notice here, sale total, let's just go through it. This method knows about the name of that class, which sends this message, which does a database query. Now, if you write tests like this, what this means is, the amount of time it takes to do an action in the CPU versus the amount of time it takes to do I/O across the network, we're talking like 1 inch to many miles. It is really, really, really slow to go read the database. And as your app grows and you keep on doing this, your tests get slower and slower and slower. And there's a point in time, if you do tests like this, if you insist on running the slow-running operations of your collaborators in your tests, there comes a point when your tests, here, let's just look at that again. There comes a point through the power of Keynote when your test suites fall down. All right? Now, what you could do instead here, the problem here is I am dependent on the name of a constant. I'm dependent on a class. And instead, what I ought to do is depend on a message. I should depend on a role. If I were to depend on a role, what I could do is I could inject an object to play the role, and I could depend on that injected variable. Now, if I did this, and I know, okay, some people hate this. Well, I don't know how you guys are doing in the PHP world, but we had a big knockdown, drag-out fight in Ruby a couple years ago about dependency injection. Yeah, good. Thank you. I love you. Maybe I should move to PHP. So, okay, stop that. I'm going to run out of time if you do that. Okay, so stop. So it is true that I raised the level of abstraction here by adding a level of indirection, which made this more complicated. I absolutely stipulate to that. However, I'm really insistent on writing very short methods. And so I find that I am not, and again, I totally understand that what you're used to seems normal and easy. And if you were to lodge this complaint about me saying this, I would agree that you're right, because this is what I'm used to, and it seems normal and easy. But I really, truly believe that in a method this short, that it is not confusing to do that, to add that level of indirection. Injecting that dependency gives me a seam, and it means that I can create another object to play that role and inject it instead. And so let's just do that. I could have an object that looked like this. And to me, these two things are equally valid. There is no difference between this thing that knows total and that thing that knows total. They're the same thing. And I'm going to depend on what I can do in my test now. In the test for foo, I'm just going to move that up to make it a little easier to understand that. And the test for foo, I can not take the default. I can inject another player of the role. And this test runs fast. Now, this allows you to avoid stubbing in the object under test, or stubbing in your collaborators, or stubbing in your collaborators, or mocking your collaborator, right? All those things that I've heard talked about here today, it is like when you start using mocking and stubbing in the objects that you're testing, you can easily get in a situation where your tests are in green, but your code is badly broken because you have too little reality. In this situation, if you'll just use the classic tenets of OO and inject your dependencies as role players, then you can make other objects that play those roles and use them in your tests. And so it is true that if I'm in my test of sale, maybe I'm running database queries when I test that total method. Yeah, okay, that's a slow running test. It doesn't run very often. I might put it in a different test suite. But I can promise you that I am not going to do database I/O to test my object foo. I'm absolutely not going to do it. This test asserts that the proof here is that if you invoke sale total on foo, that it returns whatever model total returns. You do not have to test the database framework that you got when you test your own code. If you don't believe that Taylor's framework works, you shouldn't be using it, right? That's got tests. I'm sure it does. I hope it does. I'm sure it does. I realize this is a big OO idea, right? The official term for this is composition. This is OO composition. So I'm going to inject a role. I'm going to inject an object to play the role of the thing that varies. And it's a really great way. Like you want your test to have a lot of reality. Like when reality is cheap, yeah, let's be real. But when reality is expensive, I have no compunction against creating other objects to play those roles that are faster to test, that are cheaper to run. So this is incredibly fast. It's really, really, really fast. And so now we're going to do one more thing here. Actually, let me just back up and make sure I said everything. Yes, I did. Okay. So one last thing, and we're done. One last bit of code example. Duplicated code pull-up method. I got these things. So now notice how the bits of code that I'm having to work on are getting smaller and smaller and smaller. And it's because I didn't tackle the whole thing unless I just took the code smell I understood the best and fixed it. And then I went to the next code smell and I fixed it. I went to the next one, I fixed it. Here I have this duplication. And it's interesting here, so the total method on expense only works to total the field date and to sum the field cost. And it would be really nice, now that I'm down to this point, it would be really nice to add some speculative generality here, if I could do it without raising the cost of my code. And so first of all, I'm going to remove that duplication. I'm going to make in Ruby, we have modules, they're mix-ins. And notice this line of code looks a little different than these. So basically what I've done is pass in, I not only have the where and the sum, but I've passed in a variable to use in this place and a variable to use in this place. And that's what we've done here. So it's like date field. The syntax is a little different, don't worry about it. It's a Ruby thing. So I'm summing on instead of summing cost, and my date field is date field, and my range is within. And so so I've yet again introduced another code smell here. I've made it possible to use my total method to total up on different date range fields and to sum different attributes. But again, this is a kind of speculative generality that I'm very comfortable with because I think it's easy to understand. I'm injecting dependencies instead of knowing the names of things in my 1 or 2 line methods. So it gives us a level of indirection via the parameters that got passed so that I can change my mind and inject different things in there. So that's the moral of that story. Dependency injection is awesome. You should use it. Don't let anybody, I don't know if people are trying, again, forgive me, because I don't really know what the fights are in the PHP world. But if you're having a fight about this, just like, turn your head and walk away. Just do it. It'll make your code easier. And so now I can just, in Ruby, I would just include that module, extend totalable, and then we're done with that. So really, that's the moral of the story. Learn some code smells. These ideas That book was published in the early 90s. And so it might, for those of you, we're a frighteningly young industry. So for those of you who were born since then, it might seem like they're from the Old Testament of programming. But those guys were really good at OO. And we shouldn't let the sometimes academic language of that or our lack of knowledge about those things to prevent us from stealing their very good ideas. They're smart people, and we should do these things. What it means, if you know these things, it means that many problems that you have in coding can be solved by purely mechanical operations. And I know that might seem like it's going to take the fun out of code, but I promise you it doesn't. What it does is it makes the boring things safe and easy, and it means you can save your brain power for the problems that really matter. It's like putting on glasses. So you turn that fuzzy mess that you can't understand into code that looks like this. Nice little atomic, reusable pieces. I couldn't find a really good picture. Okay, so the last little bit, there's tools. And it can be hard to identify code smells yourself when you first start looking at it. I talked this morning to, I'm sure he's here, up there. I'm sorry, and it starts with a C. Colin, who pointed out that PHP Scrutinizer might be a tool that you should look at. Like, run some static analysis tools in your code and start trying to think about what code smells they tell you. So you don't really, it doesn't really, code smells really aren't all bad. I introduced as many as I took out. But I let knowing the smells and the refactorings that went with them guide my programming to let me do horizontal refactorings that were achievable in short periods of time. You should just lean into smells. I have a new puppy. I resisted the temptation to put his picture in this talk. That is not my dog. So smells are really information. They're often neutral, right? If you're trying to lose weight, maybe you should avoid pizza. If you've been on a long bike ride, best smell ever. So last slide, this is the last thing. So when I look back at my old code I wrote 5 years ago, 3 years ago, I often think, this is a quote, what fool wrote this? And it's a really wonderful thing. Like, think about how terrible would it be if we were in a business where we couldn't look back at our efforts from 3 years ago and recognize that we had improved. I would hate that job, right? It's kept us going. It's kept me in this business for all my long life. I've been writing code because every day I look at code from 2 years ago and I think, well, that code sucks. What fool wrote that code? And so code smells, like if you don't know code smells, if this body of knowledge is new to you or you just thought it meant, I hate your code and I can't tell you why, it's time to go break open Martin Fowler's book. He's rewriting it right now. If you wait 6 or 8 months or a year, you might get the updated version that's using modern languages. So I opened this talk. I started out with a cup of coffee, and I'm going to end just the same way. Tonight, when it gets late, we're all going to go out drinking, in an adult way, in a very careful way. And when I have a 5 a.m., I have a 7 a.m. flight tomorrow, so I have to get up at 5. So probably I won't drink any coffee late tonight, even though I'm tired. But in the morning, it'll be the perfect thing when I get up. So learn some smells. Thank you. I wrote that book. I have a new, the beta of this is out as of last week. So if you have, let me just say this, I can't do the sale thing because that's too creepy, but if you bought it and have been reading it, I would love to hear feedback. So find me as soon as I get a drink in my hand. All right, there we go. Thank you. Enjoy the evening.